And welcome viewers to the Daily Space Weather Show. Put on your shades, stop your grinning, and drop your linen. It's exciting times for space weather continuing. So yeah, likelihood of an X-class solar flare remains very high on that far side western southwestern limb. And my, have we got some fresh imagery for you today. As you may have come to expect from the Smash News Network, least busted name in news. And guess what? Additional coronal mass ejections headed toward Earth. That is a 24-hour video from Solar Dynamics Observatory observing ionized helium. 30 frames per second. And yes, additional CMEs are headed in Earth's direction. Here we've added one of the species of ionized iron covered by the SDO 171 angstroms, the house favorite wavelength. It'll help highlight filaments in the lower quiet corona. There's a little closer view, and right now the sun is like a loaded gun. It's got a whole bunch of different things oriented toward Earth. The likelihood of a significant proton event is very high, which could cause polar radio blackouts for a week. But in any case, there are lots and lots of huge filaments pointed right toward the Earth. That view doesn't give it justice, as the solar corona is very bumpy, and there is a lot of dense and massive material suspended in it. So this new sunspot has been looking promising, but I don't think it's as high of a likelihood of producing a large solar flare as NASA's forecast. We'll show you that here in a moment. But like I said, the real place to watch is the T-mass, the most active sunspot. That crazy group setting in the southwestern limb. So yeah, that ain't bad. We'll take it. And we'll also take a look at the last 48 hours. You can see the transit from center disk until... The heck? What's up with that? You'll see a transit from center disk. Let me speed that up, actually. And did you know we commonly make the videos in one take? They're basically designed like a live stream. We have the capability. It's just that certain streaming platforms, YouTube, lack certain features that the channel needs. Anyway, continuing on, we'll also look at some things going on planet Earth for a brief moment here before we get to our meteorology segment. Thermal anomalies on the Reykjanes Peninsula of Iceland. So basically what's going on there is lava is coming out of the cinder cone and then entering underground tubes. So it's becoming lava, turning back into magma as it goes back underground, and then turning back into lava at that southern thermal anomaly. Calculations have been made about the amount of real estate that Iceland has been gaining. Yes, Iceland, it's growing via that most recent volcanic eruption. Kamchatka, volcanic ash not identifiable. At least Kluchevskoy. Shivaluch, same thing, yet they're on the list. Increased thermal signal there at Abiko. And an 11,000-foot plume of volcanic ash, so some lava there. Ibu, also erupting. Semeru, Dacono, Sanchaguido, Fuego, Nevado del Ruiz, and Sabancaya, all on the list. Earthquakes are as follows. And by the way, folks, notice how we don't on the channel go through and read news headlines, reading other people's stories. We show data and make actual comments on it. Do you understand the difference? Oh, man. Our viewers are not that deranged that they need us to read news headlines to them. All right. So anyway, these are the quakes of a 5 and greater magnitude. Look at all the U.S. quakes that have happened. Although none will be reported here because none are over a 5 magnitude. Panama had a 5.5. Loyalty Islands had a 5.5 as well. Only about 3 minutes apart there. So Panama and then the West Pacific. Then a lull in 5 magnitude action until New Zealand has one well to its north. And then Tonga, a 5.4. That one's at extreme depth over 220 kilometers. The Benin Islands there south of Japan had a 5.4. Funashikawa had a 5.1. That was at 11:40 this morning, Universal Time. And lastly, Taiwan, yet another aftershock on the Isle of Taiwan. That 5.1 at 18:11 Universal Time. And let's get back to space now. If somebody says energy from space, is increasing, please discount everything that they say, because that is a meaningless statement. All right? Energy from space is increasing. We hear channels that are forecasting doomsday for various ridiculous, nonsensical reasons that aren't sussed out by the data, saying this all the time. Ooh, energy from space is increasing. Is it because the sun's rising or something like that? Is it because of moonrise? Visible light's increasing? Like, what kind of energy? What do you mean? Are you talking about gravitational waves? Are you talking about ultraviolet light? Are you talking about X-ray emissions? Are you talking about cosmic ray flux, gamma ray? Like, seriously, don't. If somebody says energy from space, they are not a science person. That is too vague of a thing to be taken seriously. So, think of them like tiny atomic bullets that are just the atomic nuclei. They're just flying through space at a significant percentage of the speed of light. That's what cosmic rays are. And there are areas in the world that are designated to measure these things, all right? We're measuring the secondary particles and stuff, muon detectors, neutron detectors, and so forth. We're ultimately, because they're moving too fast to really see, folks, but they cause things to occur. Particle showers, muons, they cause ionization, they cause nuclear fission, so yeah, you get free protons and all kinds of funky things happen as a result of cosmic ray flux. And of course, it's looking increasingly likely that cloud cover, we know that cloud cover is somehow related to cosmic ray flux, which sort of relates cosmic ray flux a little bit to things like climactic cycles. So anyway, but I digress. Here's the cosmic ray report. This is just part of the daily space weather content. I don't want to get into the entire theory of cosmic rays and so forth, but so we're going to look at a couple monitors here. There's Antarctica DOMB, a little bit of an uptick in the past 30 days at cosmic ray flux. DOMC looking like the same graph there, a tiny uptick of the past 30 days. At Oulu, a small uptick as well. Now keep in mind, folks, again, I know people keep saying it all the time. They're saying, oh, energy from space, spooky, spooky energy. Look at this graph. What does that say? There's 2024, there's 2004, all right? So as far as the energy from space, from cosmic rays, it's at a 20-year low. A 20-year low. So, yeah. Now, keep in mind that this is basically a proxy for solar sunspot cycles with a lag time of like about 5 months, and it has to do with a little hypothesis that I happen to have that wasn't exactly a valid hypothesis based on the way it wasn't sussed out by the data, you see. And we'll talk about it at some point, but certainly not on tonight's daily space weather video. So cosmic rays up there at those detectors, Also up at Mexico City. Just a tiny bit, by the way. Again, it's at a 20-year low at all of these sensors. These are 30-day graphs. Athens we're going to ignore because it's missing 10 days. And then we'll look at Patati and Barentsburg. So there's a Patati neutron monitor, slightly up over the past 30 days. And here is Barentsburg. Also a slight uptick for the past 30. So again, if people are saying that cosmic ray flux is increasing, they're either not looking at reality or they're lying. They're either mistaken or they're lying to you. And there are certainly, shall we say, a few grifters on the internet. The world's going to end because, therefore, move to my compound. Buy this overpriced real estate at this location because otherwise you'll be washed away by the ocean. Anyway, if you enjoy the content, press the like button. If you're new to the channel, press subscribe. If you'd like to see the world's most comprehensive daily space weather content, there's no substitute for our channel content. So, and with the emphasis on private space flight only increasing, the likelihood that you'll go to space is increasing. The likelihood that I'll go to space was already determined in about 2012. So, but in any case, press like, share, comment, etc. as seemingly nobody sees the videos despite the channel being monetized, incentivizing YouTube to promote the content so that their ads play, right? Last I checked, that's the way it works. Anyway, the 10.7 centimeter radio flux is at back to 211, I think, but we've got to show something else here. Some more spectacular solar imagery from SDO. So there ye go. Another 24-hour video. We had some flaring from that northern sunspot group as well. Here's back to 171 angstroms. And of course, we have the obligatory viewing of that setting sunspot in this wavelength. It looks like a battle between celestial scorpions. An electrical battle between celestial scorpions, if you ask me. But yeah, that's not something I say every day. That is just... That's like, whoa, dude. So gnarly. Dude. Can you, believe that is, totally going on for the past, 24 hours? Right there, up in the sky. It's cry. Let's talk about solar cycles. The 10.7 centimeter radio flux is the proxy that we have for sunspot cycles. So sunspot number and 10.7 centimeter radio flux, they're proportional to each other. So when you have a high radio flux, high sunspot number, and so forth, check it out. Sunspot number vastly exceeded radio flux in this little uptick. So that was an interesting thing, right? So you can see that red line there, that's a sunspot number, made it all the way up over 280. Radio flux only made it up to about 227, I believe, was the highest number we saw for the 10.7 centimeter radio flux, represented there by that black line. Now let's talk about cycles. Solar sunspot cycle 25 has now emerged as a stronger solar sunspot cycle than cycle 24, cycle 12, cycle 14, and cycle 16. So, once again, if any channels have been telling you, oh, it's the weakest two solar cycles in hundreds of years, well, solar cycle 24 was the weakest solar cycle in hundreds of years. But besides that, you could make some argument that cycle 14 was nearly the same strength as cycle 24. Average-wise, it's got to be very close. But again, I digress. Solar cycle 25 has now exceeded cycle 16, cycle 12, cycle 14, and cycle 24. So, not that weak. It's average at least, probably slightly above average. It could still exceed solar cycle 23 technically. So there's that. Next is our space weather enthusiast dashboard, and NOAA's doing a half-hearted forecast here. They're calling for mild geomagnetic unrest tomorrow night into Friday night. Tomorrow night into Friday morning, rather. Yeah, so Thursday night into Friday morning, geomagnetic unrest. The rest of the forecast there is not going to be covered yet because they're only showing 3 days. Now, if you look at NOAA's Enlil spiral, it's the same scenario. NOAA's not really forecasting any impacts, while the ESA and this channel continue to agree on these minor impacts. Now, the one we forecasted yesterday looks like a major impact to me. It looks like it's going to be a KP7 major geomagnetic storm of G3 class. Let's hope SpaceX isn't launching satellites into that one like they did when they lost. What did they lose? 88% of their satellites or something? Yeah, it would have just saved them $50 million if they would have watched our channel, but no big deal. No big deal. Don't consider the implications of not listening to me. So, here is our ESA and Enlil spiral, and as you can see, 3 more CME events are on the way. One of them is a double peak, because one of those is today. It's probably at a higher speed than the previous one. But yeah, as you can see there, multiple events headed toward Earth. ESA and the Smash News Network least busted name and news agree. Now, this is bad data right here. So there are the past 4 hours modeled by the Space Weather Modeling Framework, and they must be using the ACE as the active spacecraft. So that's an issue because the ACE is showing very low and very slow solar wind density. They need to switch to the Discover, in which case you'll see a signal there. It's garbage in, garbage out, folks. If you don't have the right data, you will have a bad model. So it's showing no magnetic flux density changes at the ground either, which is what that depicts. That depicts changes to the Earth's B field, and it's showing the Earth's B field as shockingly stable right now because, well, it's using 1/10 of a proton per cubic centimeter for the solar wind density and a solar wind velocity of under 400 kilometers per second. So that's not likely to be the correct data, but KP index is not based on that. This is the average of global geomagnetism, and it's KP 0.67. Not that. 0.67 is the KP index. So check it out. Here's the active spacecraft that's used for that model, and it's only detecting 0.2 of a proton per cubic centimeter at only 361 kilometers per second. So that's very weak. Let's just move to the Discover, which has more reasonable and believable data. Now, we are seeing a couple of minor brush pass type impacts here. We're seeing this background signal and then this longer duration impact. These are some of the events that we've been forecasting. So they're showing up here very mildly, as you'd expect. But again, like I said yesterday, there's a major one coming. And it's going to hit a little harder than the rest of these. But current conditions are elevated. So we are seeing an impact happening just in the past few hours here. In the past about 4 hours ago, we did have a little CME impact. So now it is just high speed, not really high density. So you've got a density of about 4.3 protons per cubic centimeter and a velocity of 510 kilometers a second. No strong magnetic field to accompany that CME impact, so no geomagnetic storm, and none was really expected. GOES magnetometers are next. We just had some maneuvering there by the GOES 16, that arc jet moment, creating some plasma by operating its thrusters to maintain its orbit. Next, magnetic sectors. Earth is in a North Pole sector. South Pole sector is coming, but not going to be here for possibly 36 hours or so, I would say, assuming no sudden changes happen. Here's our line of sight field plot. And if you had to pick just one piece of data, folks, that's a really good 4 days of data there. Line of sight coronal hole plot. And we've got south and north pole oriented coronal holes here visible from the Earth side of the disk. If you're in space and you have access to things like, well, if you've got the SDO in space, So anyway, here's the scenario. The coronal holes that are right in the Earth zone right now, these are North Pole oriented, and all of these are South Pole oriented. So that's what's going on with coronal holes. Next, we'll move to sunspots. I think they're important, right? Well, sunspot number has dipped to, it's all the way down to 259. 259 sunspots is the current sunspot number. And here's our flare probability monitor and scoreboard. And you can see that this model here is showing that this sunspot here, 3654, is the one very likely to produce an X-class solar flare, and I just disagree with that. That should be downgraded. The likelihood of a large flare is over here. That's let's just make sure of that by stopping this thing. Oh, 11? No, it's got it right. There we go. Okay. 3638. Yep, that's the one. That's the one, so I agree with that. Number 3. Yeah, number 3 also. Yeah, that's good. That's good. I'll agree with that. 61% chance of an X-class flare down there in the southwestern limb. And 21% chance of one up there. 34% chance of an M flare. That is... I am on board with that. Now, sunspots up close are next. And welcome to space. Space, a frontier. These are the voyages of the SDO. Viewing the photosphere with the HMI instrument, it's effectively the sun's surface. Let us know in the comments if you think it's an illusory surface or a real one, as it does matter. If you've heard of things like helioseismology or seen waves like ripples on a pond radiating across the solar surface, you might change your mind, but so, you know, I could have sworn I saw some growth down here. Yeah, we got a new sunspot right there. Rapidly becoming a beta-class sunspot group. So, however, if this sunspot group over here sets without significant other sunspots growing or rising, then we'll see a big decrease in sunspot number once that group sets. That's probably like about 80 umbrae as far as the sunspot number count. So here's that group that did produce an M-class flare or 3. It's been stable mostly for the past 24 hours. Its magnetic fields should largely agree with me. There is a little bit of activity there, mainly the trailing edge of that. Those North Pole trailing umbrae are looking like the ones that are the most volatile. But the overall most volatile sunspot right now remains that one. We're going to be unable to analyze its magnetic fields here moving forward until it rises again, which it likely will. However, the flare risk doesn't expire until a long time after that sets. So we've still got well over 48 hours of an X-class flare watch as a result of that behemoth and awesome sunspot group. So that one's been a great pleasure to view and watch it evolve and so forth. Let's move on to energetic particles and flares. We had a little spike in the proton flux there. Look at that. The proton flux coming back to life a little bit. And by the way, like I said earlier in the video, the likelihood of a major proton event is now majorly high. So we are seeing some solar wind components coming in. The likelihood of an X-class flare being as high as it is with the location of that sunspot group, it doesn't get any higher for SEP warnings. Major SEP warning is in effect right now. As far as the X-ray flux goes, it's fairly low. I mean, it's not super exciting. But don't be surprised to see one of these flares coming way up in this range. Don't be surprised to see that happening. Just the proximity to the limb increases the likelihood of a large flare. And of course, that is a major sunspot that's already produced major flares right on the limb, which is exciting. I'm excited. Now, we've put together 94 plus 131 angstroms. Number one, we require some closer views. Engage. So there's that group in the southeast. It's not really that exciting. These series of groups in the southwest are plenty exciting. And CMEs are coming, and we'll be covering them here in just a minute. First, some more mild stuff, like what's going on in the solar system. Here's your 1-week forecast. And by the way, you'll have Mercury and Venus in the morning sky for an extended period here, as Mercury is coming out of retrograde in like 3 days. That's where things will be in 1 week. You'll still be able to see Venus and Mercury in the morning sky. And Venus will be getting very low. And anyway, here is your star chart. At least that's our star chart if you want to make your own, skyandtelescope.org. I really like their desktop star chart. It's just splentacular as the sun chases Venus and Mercury across the evening sky. Now, the apod.nasa.gov photo is so good that we'll have to go full screen for this one. It's the Dragon's Egg Nebula, which is part of the New General Catalog. Some series of 4 numbers. And what's very interesting about the article, the caption on this, is that it's stating that the symmetrical features near the center of that, the central symmetrical features are caused by plasma being aligned to the magnetic fields emitted by that massive central star. They're also suggesting that the reason that the central star erupted, producing that brightly ultraviolet illuminated nebula, is because of an orbiting binary. So, but there you go, apod.nasa.gov, Dragon's Egg Bipolar Emission Nebula. That is a nebula that is bipolar in nature. It goes from manic to depressive. But no, seriously, it's quite exciting. It's quite exciting, that nebula, as a massive and unusually massive star located at about 3,600 light years toward the constellation Norma. Never heard of it. Must be Southern Hemisphere. Anyway, CMEs are next. So let's get me off the screen here at the Smash News Network, least busted name in news. So more CMEs headed this way. So at least one more from early this morning, once again, to arrive on the 27th. Or maybe even on the 26th. Geez. Could be late in the day on the 26th. But pretty sure that's another CME impact coming. So like I said earlier this morning, the heck? Oh, it looks like it was mid-afternoon. All right. Out of the west? Huh. All right. Mid-afternoon. I'm not liking the data. Something looks funky. Something looks funky, folks. It's a great reason to look at stereo A. Let's just manually advance this. late yesterday evening, perhaps? I think that's what's going on. It was late yesterday evening into this morning. We're just seeing the aftermath this morning. Multiple events there popping off all around the same time. And then, missing data. Geez, it's been a bad day for missing data. All right, so here's our synced up imagery. This should help things. This is a 24-hour video. It's going to show from 8:15 yesterday evening until 8:15 Universal Time. That's 1945 Universal Time yesterday until 1945 Universal Time today. So yeah, late last night there was an event out of the southwest. And then another event out of the southwest. Maybe both of those are headed this way. I think both are, but let's zoom in a little closer here to note the origins of those. Very hard to tell. All right, so one of them came from this area right here, and one came from this area right here. And certainly the one that was center solar disk will have earthly directed components. So it's kind of right behind our Earth scale there, unfortunately, but that is an unrecoverable error. Yeah, so at least one, possibly two more CMEs to arrive late in the day on the 26th, early in the day on the 27th. So that's more good news for space weather. These videos are brought to you by helioviewer.org, by the way. So check that out if you haven't. Helioviewer.org, you can make your own space weather videos. And we encourage more people to do this because, well, there is plenty of stuff to cover. And frankly, it's a lot of work. So anyway, filaments on the solar disk. We've got two massive prominences rising there, indicating more sunspots will be about to rise in a day or two. One in the south-southeast and one in the east. Like I said, the sun is currently like a loaded gun. It's got a lot of plasma filaments pointed right toward the Earth. Look at the size and density of those filaments. We only named one of them. This one right here. Right there. That one's called the Larry David filament. Right on the other side of that sunspot. The Larry David filament. Name that filament over on Twitter, if you like. Name that filament. Follow the hashtag. You can name filaments after your friends, your foes, or even yourself, and there's a reason for it, folks. The reason is it makes it easier to follow and keep track of filaments. Sometimes they just disappear off the data, and it's usually because they become coronal mass ejections, although sometimes they do reorient themselves, and that way if you name them, it's easy for people to keep track of them. It's not just for grandstanding purposes. It's actual science. The same reason we name winter storms, so that people remember which storm it is and things. And of course, they're named after living people because that's most like a plasma filament, right? Very lively, hopefully. Hopefully not a walking zombie. So yeah, that's the past couple of hours. Charging hazards are next as we get through our bonus features. Charging hazards, we ain't got none. Electron flux, just in a normal operating range there, just right around the warning threshold. That's not going to hurt you. If you're frightened of the electron flux, it's at the ionosphere, so it's not going to affect your weather at all. Next, the 1 year electron flux. There it is. Once again from solon.info. And there's a forecast model. Looks like NOAA's expecting a massive dip in the electron flux, with which ESA and I would also agree. Next, the layer where it's measured will show the vibrational frequency of that diffuse gas at the bridge between Earth and space. It's at about 300 kilometers of altitude. Here it is, the F layer. The ionospheric F layer. It's actually outside the bridge between Earth and space, but you could make the argument that the ionosphere is the bridge between Earth and space, the whole thing. Although once you get to the D layer, it's called the ionosphere Why? Because most of the particles are ionized. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And we haven't been having any geomagnetic storms, although there is one, probably two significant ones on the way. Yeah, the one that we did yesterday, I'm still expecting a KP7 from that, a G3 level geomagnetic storm. And then, let's see, the ones from today, don't expect more than a KP5 from either of those. And only one is likely to hit solidly enough to even do that. So, one major impact, two minor impacts are coming. We'll also show this. It shows the total electron content on the left, along with its anomaly, maximum usable frequency and anomaly on the right. Gotta love it. Or if you don't, let us know in the comments. We encourage rage comments. And if you're mad about this being covered, then I guess you don't like to use GPSs or high-frequency radios. Because if you did, then you'd probably care about that. But if you don't, then more power to you. I prefer to communicate using cups that are strung together with a piece of twine. That's my favorite means of communication. I've been shopping for one. Apple has been making a new product that uses the conduction of the sound through a string. It's called the Apple Styrofoam Cup Phone, and it only costs $2,000 per handset. So here's what's going on for... Did I press refresh? There we go. Let's get the last look at this group, as it will be out of sight tomorrow for the most part. It's still a beta gamma class sunspot group. I'll just say that. Yeah, the X-class solar flare risk has not expired, and let's move to meteorology and blast through it. These are the surface winds and significant wave heights of Earth's oceans. So Earth's oceans are actually quite calm right now. It's actually pretty good times to go sailing, unless you go all the way as far south as you can go in the Atlantic Ocean, then keep going south, you'll be in the Southern Ocean. There is one area there with 30-foot waves. Those are the highest seas in the world, folks. It is a calm conditions to go out on a boat fishing shirtless with hunks like Marky Mark Wahlberg and Jorge Clooney. Yes, no fear of the perfect storm unless you're in that tiny spot of the Southern Ocean, and why the heck would you be there? That would be a stupid place to be. These are the surface winds of the eastern world and the jet streams. Central world. Surface winds. Western world. Jet streams. Satellite for the Americas. Press the like button, lest thy soul be cast into Sabankaya's caldera. Just kidding, folks. Your soul can't be cast into Sabankaya's caldera. Sabankaya doesn't exist in the river Styx. Sabankaya doesn't exist in Stygia. Check out that low moving up toward Newfoundland. And here is our pressure map. So we've got high pressure dominating the Great Lakes region. That's sort of holding off these lows that are around the Rockies. And you've got this other low, like I just said, moving up toward Newfoundland. So you've got a high right in here, which is pushing down on things, and that's sort of what's controlling weather at the moment. Pressure there is 1,030 hectopascals. Next, weather.gov's map. If your location's lit on the map, you'll have to click it yourself, because click it or ticket, folks. Click it or ticket. That's too many counties for us to cover, but there are a bunch of freeze warnings, including Lehigh County, Pennsylvania. Now, models are garbage in and garbage out, okay? The reason we show 72-hour forecasts on the channel is because we don't do specific custom forecasts for a precise area. So we show 72-hour GFS forecasts because the GFS 3-day forecast model is sufficient with its inputs to be accurate. We don't show 384-hour forecasts. We show 72-hour forecasts. You see? Less than 1/4 of that, because we don't show nonsense on the channel. If we had to do a specific forecast for a specific area, I mean, Sherpas should hire me as a contractor, because for those of you who've seen our hurricane amendment forecast and our blizzard amendment forecasts, and is it going to be a snow event? Is it going to be a rain event? You may have noticed the accuracy of those. Anyway, what we're showing here is the 72-hour GFS jet stream forecast. That's the 250 millibar winds, the 250 millibar winds. The same thing we show on the nullschool.net, but this is the forecast. On nullschool.net, we show the current conditions. So that's what's going on with the jet stream. The jet stream is in charge of large-scale weather patterns. Temperature anomaly forecast is next because this is in the news. Hard freeze warnings across large portions of the northeastern U.S. So then we'll have an area of very warm air moving its way across the Midwest, making its way to the Great Lakes states in the next 3 days. Lastly, precipitation and pressure. So we've got a mixed bag of slushy, snowy, gross conditions in the northern Rockies. Pacific Northwest, mostly wetness. And that low kind of loitering a little bit before it makes its way up toward the Minnesotan-Canadian border. That's the weather. Here's the lightning. That's what's currently striking. Once again, a stormy night in Brazil. And we did have some lightning over Cuba. Does it continue? And it does. So many brujas are casting many spells. And summoning lightning, otherwise known as the Blue Dragon. All right, what do we have here? We've got some lightning here around Cheyenne, Wyoming. There's some thunder rolling in. We saw some in Nevada earlier as well. Lightningmaps.org. It's a real-time lightning map. And yes, you can use it to forecast thunder for real. Done it. It's awesome. We'll close out with Doppler. Satellite for the lower 48. And water vapor. Closing this thing out. Once again, there's U.S. Doppler radar, vertical motion in the air column. Satellite-based visible imagery. So good. So good. And last but not least, water vapor. And you can actually see how this is acting like a blocking feature. You can see this dry air. It's sort of funneling this air through this area of moisture. That's the path of least resistance. So you're getting like an acceleration of the winds here over the Carolinas and so forth. Also, there's a blocking feature right here over northern New Mexico and Arizona that is keeping this moisture from making it to the hot air capital of the U.S., known as Colorado. Anyway, here's me closing out. It's been a pleasure putting out the daily space weather content. Thanks to each of you for tuning in. We'll see you next time. And until then, may that solar wind be at your back.